Hello everyone, I'm Abhijit. Welcome to Zero to LLMOps. We are in day 3 of phase 1 of learning Linux. So let's get to the slides. Yesterday, we got fluent with the daily driver commands like moving around, managing files, and the big one, input output redirection. Every one of those files you touched has an owner. Every command you ran as someone. Today, we found out who that somebody is, how the system decides what you are allowed to touch, and how you borrow someone's authority safely when you need to. Users, groups, the account files that back them, and the difference between su and sudo. This is the day permission gets a face. So let's do a quick recall before we move on. What are the file descriptors 0, 1, and 2? And what does 2 greater than ampersand 1 mean? So file descriptor 0 is input, 1 is output, and 2 is errors. And 2 greater than 1 ampersand 1 means that redirect the errors to the output file, whatever we have mentioned. Where does slash opt sit in FHS? And why does our project live there? So OPT are optional programs, the programs that we download, the programs that we want to run, uh, which optionally we install. So the standard programs go in slash usr, and that's the reason our project lives in slash opt because we are building that thing. Now, what's the difference between a hard link and a symlink? So a hard link is just the same thing that is present in the linked file. So if you link two files and make changes, they get replicated exactly. And if you even destroy the copy of the file from which you created the link, the linked file stays because it's just like a copy. Just the thing is that whatever changes are being made get replicated, whereas a soft link or a symlink is just a pointing towards the actual file. And if you delete the source file, then you do not get the contents in the symlink or softlink file because it's just a pointing. What does journalctl-b shows you? It shows the logs from current boot, right from starting from firmware, power on self-test to your starting of the PID1 system D, and then the further system D logs. And tail-f, what is it for? And what did you use it for yesterday? So tail shows us the last 10 lines or the latest lines. But if you use it with tail minus f or tail hyphen f, it will continuously follow. F is for follow. It will continuously follow the log lines. And we used to look at our output logs yesterday. If any of this felt shaky, that's fine. You can revise it from the previous videos and let's move on. So here's the thing that we are going to learn for rest of the day. Every process on a machine runs as a user ID, a UID, plus one primary group ID, a GID, plus optionally a handful of supplementary groups. Think of your UID like your ID card, unique to you. Nobody else has it. Your primary GID is the department stamped on that card, and your supplementary groups are the other buildings your card also has happens to have access to. You belong to more than one, but you're only got one home department. Four commands show you this right now. Those four commands are id, which dumps your full picture, uid, primary gid, and every supplementary group in one line. So this is the command of id. Here the uid is 1000 student, gid is 1000 student. Groups we are in our primary group student with 1000 ID and a wheel group with ID 10. Now the whoami just gives us the name, the username. Groups list the groups. Here it is student and wheel, the groups that we belong to. id hyphen gn and some other user like fresher01. Let's us ask about the question for somebody else by name. Now these UID numbers aren't random, they are ranges and they matter. UID 0 is always root, no exception. UID 1 through 999 are typically reserved for system and service accounts. These may vary within these system and service accounts, but they are usually reserved. What is a system or service account? The things that run processes but were never meant for a human to log into. 1000 and up is where regular human starts on RHEL and Fedora. The exact cutoff lives in the file called /etc login.defs. These are the cutoffs that we meant. So where does the system actually keeps this information? Three files, and you need to know their shape by heart. /etc passwd, one line per user, colon separated, and the contents goes username, then a password field, then a UID, a GID, a comment field called GECOS, then the home directory, then the login shell. So let's look at that same file /etc passwd. We are going to cat this file. So we are user student and these are the field username, password, UID, GID, GECOS or the comment field, our home and our login shell. Now look closely at the password field. On every modern system, it just holds the letter X. That X is not the password, it's a pointer that says the real hashed password lives somewhere else. Go look in a shadow file. That somewhere else is /etc shadow. So let's look at that file cat etc shadow. So it has got the same idea, one line per user, but this one holds the actual password hash plus a run of aging fields such as last changed, minimum age, maximum age of the password, warning period before the password should be changed, inactive period of the password, expiration, and critically, this file is readable only by the root. That's the reason we used sudo while doing cat for it. That's the whole reason the X trick exists. /etc passwd has to be world readable because dozens of tools need to look at usernames, but nobody outside root should ever see a password hash. And the last file is let's cat it /etc group. Now the /etc group mirrors the shape of groups. It has group name and an X placeholder, a GID, and a comma separated list of members. So here we see the list of members, fresher01 in this case, or for wheel, we see the list of members, student, DevOps trainee, and fresher01. So I hope you got the hold of all three files. Now that you can read these files or know the model, let's talk about the commands that change it. To create a user add -m -s /bin bash -c in the double quotes, the comment you want to give, space, the name. So here, the -m flag is the one people forget. Without it, no home directory gets created at all. -s sets the login shell. -c fills in the GECOS comment field we just saw in /etc passwd for our student user, which was having electrical department. To create a group on its own, group add space name. To modify an existing user's group membership, user mod hyphen small a capital G, then the group name and then the username. But here I need you to burn this into your memory. Always use a small a together with hyphen capital G. Here's why. Hyphen capital G alone means set this user's supplementary groups to exactly this list. It replaces everything, wiping every other user groups they were already in. Hyphen small a means append. Add this new group. Keep everything they already had. Think of it like issuing a new key card. Hyphen small a capital G adds one more door to the set of doors you can already open. Plain hyphen capital G without hyphen small a conflicts the whole batch and issues a brand new one with only the one door you just asked for. And if wheel, the sudoers group, wasn't on that new shortlist, you just locked yourself out of sudo. We are going to deliberately trigger this trap in the lab so you feel it once and never forget it. One more modify pattern worth knowing now. Usermod hyphen small s space slash sbin slash no login space user. You use this on service accounts, the accounts that exist only to own files and run a process, never to have a human sit down and log into them interactively. Slash sbin slash no login politely refuses any interactive login attempt while still letting the account own files and run jobs. We'll create exactly this kind of account for our incremental project in a few minutes. I'm not going to run useradd live on this slide. Creating a real account is lab work, not a demo. So we will do it together on purpose in a minute. Let's go to the second half of the user management, passwords, deletion, and how to look things up without guessing. Passwd user sets or changes the user's password. Run by root, it can set anyone's. Run by a regular user on themselves, it prompts for the old one first. Chage hyphen L user shows you the aging report for an account when the password was last changed and what's the max age and warning period window. Chage hyphen capital M 90 user sets that maximum password age to 90 days. We just read that slash etc slash shadow line by hand a moment ago. Chage is simply the friendly command that edits those same fields for you instead of you touching the file directly. Deleting userdel hyphen r user. The hyphen r matters. It removes the home directory too. Without it, the account disappears, but their file sits there unowned forever. And with the hyphen small r, it's a clean removal, which also means it's not reversible. So double check the username before you hit enter. And for the inspection, the command that works no matter where user information actually lives, local files, LDAP, wherever your system is configured to use, is getent, Getent. So getent passwd user and getent group asks the same question. Cat slash etc passwd would, but through the proper lookup path called nsswitch. Instead of assuming it's always a local file. On our lab machine, it will match the slash etc slash passwd exactly, but on a real enterprise system, it might be pulling from a directory service instead of our slash etc passwd locally. Getent doesn't care, and neither should you or your script. Now let's look at ourselves up with the getent command. So getent passwd dollar user. It just gave us the line from slash etc passwd exactly where we have our username, password, user ID, group ID, GECOS or command field, our home directory, and our login shell. Now, in a single view, let's have our shadow file open. Along with that, we will run the chage-l command as well. So let's open our shadow file. Note this line here for the student user and these fields. So here it is. This is the epoch time for last password change, that is 8 July 2026, and these are days between password change, minimum days, maximum days, and the number of days warning before password expires, that is 7. Now the part everybody asks about on day 1 of every ops job, SU versus sudo. They both let you act as someone else, but they work completely differently, and mixing them up is a real common mistake. SU hyphen user. Let me repeat it. SU space hyphen space user switches you entirely. You become that user. Full login shell. Their environment reloaded because of that dash. And critically, it asks for their password, not yours. Think of it as putting on their entire uniform, badge, office, the works until you type exit and go back to being you. Sudo command, on the other hand, is completely different in its spirit. It runs one single command as another user, and that too root by default, but it asks for your own password, not theirs, not the root users. You never become them. You borrow their authority for exactly one instruction. Then you're back to yourself. Think of sudo as a permission slip, signed and filled in advance, that lets you walk through one specific door one time using your own ID to provide your access that you are allowed to hold that slip. That permission slip is a real file. Let's look at it. It's in /etc sudoers. And look at this. While I do the cat for this file, I'm using sudo. That is, for doing the cat /etc sudo, I'm exactly using or getting the one-time permission to do a cat on etc sudo file. This file defines exactly who gets to run what and as whom, and you never open it with a editor like Vim or any plain editor like Nano as well. Always use vi sudo. The reason is simple and important. Vi sudo syntax checks the file before it lets you save, so typo can't leave you with a broken sudoers file that locks every single admin out of sudo at once. We would happily save your typo and hand it over to the system exactly, and that will become a disaster. The basic sudo syntax reads almost like English. A username space all equal to in the bracket all space all. Let me point to the root. So this is root user all equal to in the bracket all space all. So here it means this user on any host running as any user can run any command. What does it mean? Allow root user to run any commands anywhere. And the group form is mentioned with this percent. So whatever has a leading percent in it, it's group. So here we look at percent will all. So whoever is in wheel group can actually run any command anywhere, is allowed to do so. So membership in the wheel group is what grants sudo. That's why we cared so much about hyphen small a capital G wheel a moment ago. You get that wrong and you lose sudo entirely. Two more commands worth knowing. Sudo -l asks, what am I actually allowed to run? Your own personal readout of the sudoers rule that apply to you. And sudo -u space user space command runs a single command as a specific non-root user, which is exactly how we will test our service account later today. let's look at the sudoers file itself safely with the vi sudo command. So we have opened our file in editor mode here using vi sudo. Now let's locate our wheel group which grants all commands to run all people in that wheel group anywhere. Let's not change or save anything here. And at the end, let's look at sudo hyphen l, what things we are allowed to run. So as we are in wheel group, we are allowed to run all commands anywhere, but with the sudo privileges. So now let's go over the last piece of theory, and it's mostly that you should know that this thing exists rather than something you will configure deeply today. Underneath every login and every sudo prompt sits a PAM, pluggable authentication modules, configured under /etc pam.d. PAM is the bouncer at the door. It's the layer that actually checks credentials and enforces policy at the moment you authenticate. We are not diving into writing PAM rules in this course. Just know the name and know it's there doing the checking every time you type a password. The rules PAM enforces mostly come from /etc login.defs. Things like pass max days, the maximum password age system wide, pass min len, the shortest password the system will accept, and the UID min, UID max ranges we already mentioned. The file that actually defines where system accounts and human account begin. And finally, locking an account without deleting it. passwd-l user locks, passwd-u user unlocks, usermod capital L and usermod capital U does the equivalent thing. This is the move that you perform when someone leaves the team or a service account looks compromised and you want that account frozen but still intact. Files, home directories, ownership, all preserved instead of nuking it with userdel. Let's peek at the policy file and then PAM directory just to see they are real. So here we just are seeing at login.defs and we see password max days, UID min, UID max, all those fields that we discussed. And let's look at pam.d. So here we see all these policies. It's not in our scope to learn about these files for this course. Now that's the theory. We go hands-on for the next 2 hour. You should actually do the labs for 2 hours, and you should be typing the commands that actually change the system. Now I will attach the assets. However, as we are doing all the commands, so follow along with me on your terminal as well. That's the actual learning. If you go ahead and just copy paste from the attachment, you won't learn anything. So the first thing we do is read the real account files on this box and find out ourselves root and system accounts inside them. How do you do that? cat/etc passwd, and here this is the root user with UID 0 and his shell and his home/root. Then after that we have our system accounts from 1 to 999. Here we have 995 last chronic system user, and then starting from 1000 we have our own accounts or the real user accounts. We should look at etc shadow file. You can see the user accounts and they are having their passwords. Whoever have their password set. Root doesn't have its password set, so it has exclamatory marks, whereas our student user and other users are having password set and their aging fields. Same way you should look at cat/etc group. So we see the contents of group file here too. Now in this part 2 we should create the real accounts. You can follow along with me, as on this system I had already created a group and user called as DevOps trainee and fresher 01. We will create another group and another user. So let's say LLMOps users. We want to create a group called LLMOps users. So we will simply do sudo group add LLMOps users first, then in that group. So let's add that user. Sudo user add -m to create its home directory, -s slash bin slash bash to provide it a login shell, bin bash -c the command field, ops engineer for LLM ops capital G, and then the groups. First, the group that we added, LLM ops users, and then its own group and the username, that is ops user 01. Now let's set a password for this newly added user. Sudo passwd ops user 01 new password. Now let's change the user to ops user 01. Here it asks the password of that user, that is ops user 01. Let's give that password. We have logged in as the ops user 01 now. How can we check it? We'll run whoami. I am ops user 01. Then the ID command. My UID is 1004. My GID is 1006. My primary GID or group is ops user 01. And then I am in these two groups. My primary group ops user 01 and LLM ops users. Now let's exit to our own shell, that is student. We have came back to our own shell. We can also demo here that we can check the user and groups of other users from student user, because we already saw that /etc passwd file is readable. Now let's look at the aging report of this user. Sudo chage -l ops user 01. This is the warning period. This is maximum number of days between password change. These are minimum number of days between password change. So, and uh, last password change is on August 1st, 2026. The password never expires. Now let's set a 90-day maximum password age. Sudo chage capital M 90 ops user 01. Let's again confirm. We have changed the maximum number of days between password change is 90. So password will expire on October 30th, 2026, and we will get a warning 7 days before the password expires to change the password. Now let's go to the part 3. Let's look at sudo and sudoers. Now let's give our user the permission of sudo. So here we are adding the ops user 01 user to the will group. Now to check whether ops user 01 is in the will group, we simply write groups space ops user 01, and here we can see it has been added to the will group. Now let's log into our ops user and let's check whether it has got the sudo permissions. So here we see that it has got all permission to run all the commands on all the hosts. So I deliberately added a new user called as ops user 02 and didn't add it to the will group. So it says sorry, user ops user 02 may not run sudo on DevOps lab, whereas our ops user 01 can run all the commands. Now let's run the trap that we were discussing about. So let's do sudo usermod -a capital G to add the user in group, LLMOps users, and $user to substitute our own user. Now let's look at. So here we did sudo usermod capital G LLMOps users ops user 01, and then we checked which all groups the ops user 01 is in. Earlier it was in will, now it has been removed out of will because of our mistake. So let's again add the user to will group, or otherwise let's first check whether the user is able to use sudo command. So we can see that the ops user lost its ability to use the sudo commands because it's not in the will group. Now let's rectify our deliberate change and add it to the will group. Now let's demonstrate how to run a single command as another user without a full su. Sudo hyphen u ops user 01 who am I. So we were able to run this command as that user itself. Now let's look at our incremental project. And this is for your homework. Create the service account. The project will run under from now on. So the commands will go as sudo user add hyphen small r hyphen small s slash sbin slash nologin hyphen d slash opt fresher project hyphen c project fresher project service account svc underscore fresher. So screenshot this sudo user add hyphen r hyphen s sbin no login hyphen d opt fresher underscore project hyphen c fresher project service account svc underscore fresher. So hyphen r equal to system account, no login shell. It should never be a interactive login. Now let's change the ownership. Sudo chown hyphen capital R svc underscore fresher colon svc underscore fresher opt fresher project. So here we changed the ownership. Now let's run the bootloader.sh as that account. So sudo hyphen u svc underscore fresher slash opt fresher project bootloader.sh. So definition of done for next day would be if you are able to explain passwd shadow groups field from your memory. Now let's do a recap. Every process runs as a UID plus a primary GID plus supplementary groups. etc passwd, etc shadow and etc group are where the model actually lives on disk. Creating and modifying accounts is user add, user mod, group add, and hyphen small a capital G. Never bear capital hyphen G or you wipe someone's group membership. SU hyphen becomes another user entirely, while their password sudo borrows their authority for one command using your own password governed by slash etc sudoers. Always edit with vi sudo and password policy PAM login.defs and account locking is the plumbing enforcing all it at login time. Homework, you should be able to explain the passwd shadow and group fields from memory, confirm that fresher 01 and DevOps trainee exists like we did for ops 01 user and LLMOps users. You should create fresher 01 user and DevOps trainees group. Confirm your wheel membership via sudo hyphen L command and confirm that SVC Fresher owns slash opt Fresher project and can run bootloader.sh. Three questions before we close. What does the X in the password field of etc passwd mean? Why must you use hyphen small a with user mod hyphen capital G? And what happens if you forget it? And why give a service account like SVC Fresher a sbin no login instead of bin bash? So answer these questions. Tomorrow is day 4, the permission deep dive, RWX and octal notation, umask, SUID, SGID, the sticky bit, and ACLs, access control lists. And we'll finally look down, lock our slash opt fresher project properly.